Hello, everyone. My name is Anuj Sahani, and I'm a solution architect here at Couchbase. I enjoy working with the cloud technologies and helping customers with their digital transformation journey. Today, I will walk you through some of the best practices of deploying a highly performant and a self-healing Couchbase cluster in the Kubernetes environment. Here is a nice and short agenda of my presentation today. I would first begin by introducing Kubernetes high-level architecture and some of the important terms which we will later use while discussing the best practices. Next, I will briefly talk about Couchbase Autonomous Operator and how it enables us to deploy a self-healing, highly available Couchbase architecture on any public cloud. With some understanding of the Kubernetes and Couchbase Autonomous Operator, we will then get into the best practices section. I will share some of my experiences that I gained while working with the cloud customers. And no cloud presentation is complete until we see things in action. So I will be deploying a Couchbase cluster on Amazon's EKS platform using most of the best practices discussed in this presentation. One important thing, please feel free to ask questions via chat channel, even during the presentation. Let's take a look at the Kubernetes architecture first. Here is the three-tier architecture. On the far right, you have a set of worker nodes, which are also called as nodes, that run containerized applications. These containerized applications are run within the pods that are hosted within each worker node, aka nodes. The kubelet is the primary node agent that runs on each node. It registers the nodes with the API server, running in the control plane using the host name so that control plane can communicate with the worker node. kubeproxy maintain network rules on the nodes. This allows network communication to your pods from the network session inside and the outside of the cluster. Without the kubeproxy, you cannot reach to the pods running within the nodes. Now let's take a look at the central layer, which is also called as a control plane. The control plane manages the worker nodes and the pods in each cluster based on the inputs it receives from the end user. Just to highlight some of the components of the control plane, in no particular order, we have the API server, which is the front end of the Kubernetes control plane. The scheduler main job is to place each pod on an available node that can guarantee the resources it needs. etcd is the key value data store that backup cluster-wide configurations. Control manager is a collection of various controllers, and their overall purpose is to monitor the health of the cluster and respond to resolve the issue. This slide represents the same information as last one, but orient the architecture differently. Rather than showing worker nodes individually, I have a bigger box called node group, which encapsulates smaller boxes called nodes. So you can say a node group is a collection of worker nodes of one specific instance type. You can have many different node groups in a Kubernetes cluster if you like, but you can definitely start with one group in your cluster. The other important thing I want to highlight is the persistent storage. When pods get placed within each node, they get an ephemeral storage, which means when the pod dies, you may lose all the data on that pod. But to build a database, you really need the data volumes that can survive the pod failure. So persistent storage provides you the mechanism to mount storage volumes that are more reliable, durable, and elastic in nature. Just building on top of the last diagram, you can have a Kubernetes cluster with multiple node groups. Generally, different node groups have instances of different resource types. As you can imagine, this design makes it very easy to scale up as well as scale out different components of your application. Now that we understand the high-level architecture of the Kubernetes and how it provides a self-managed platform for applications on cloud, let's now talk about the Couchbase Autonomous Operator. In the nutshell, Couchbase Autonomous Operator is an application-specific controller that extends the Kubernetes API to do three important things. It enables the provisioning of the Couchbase cluster based on the desired dimensions specified in the YAML file. It configures the cluster by assigning the required amount of resources like CPU, RAM, storage, and others, and it monitors the state of the cluster. As described in the diagram on the right, the self-healing aspect of the Couchbase autonomous operator works by continuously observing the current state of the cluster, comparing it with the desired state of the cluster, and once a change is observed, then acting upon to resolving the outage by bringing a new pod to the cluster as a replacement. Now let's map the Couchbase autonomous operator architecture to the Kubernetes stack. As you can see, there are two specific pieces to the operator. The first one is the Couchbase admission controller, whose most important job is to validate the YAML configurations before acting upon it. And the second piece is the Couchbase operator, which essentially provides all features and functionalities of provisioning and orchestrating Couchbase cluster within a Kubernetes platform. And this is how a Couchbase cluster deployment may look like once you execute the cluster YAML file. We will see this more in action during our demo section. Let's talk about why you should consider using Couchbase autonomous operator. Well, first and foremost, it enables you to provision your Couchbase cluster on a private as well as any public cloud platform like Amazon, Microsoft Azure, Google GKE, Red Hat OpenShift, without worrying about the infrastructure challenges. It automates the provisioning of the cluster by utilizing the best practices throughout the stack. In Operator version 2.0, we have centralized the management of RBAC as well as introduced the support of LDAP right from a single resource file. It makes the life of a DevOps or an SRE easier by providing out-of-the-box automation for provisioning and configuration of the cluster as per your business needs, upgrading and patching the cluster, which may take days of planning and execution if done in the traditional manner, monitoring by tightly integrating with Prometheus. And one of the latest features that just got GA is the regular backup capability. All these features working for you to reduce the effort to manage the database system so you can spend more time utilizing it. Now let me share my top 5 recommendations when it comes to deploying a production-ready Couchbase cluster in the Kubernetes environment. The first one on the list is to always host one and only one pod per worker node. And because we are going to host one pod per node, it becomes even more critical to size the node right, as we don't want to overcommit or undercommit the compute resources on our Kubernetes cluster. When you have multiple node groups in the Kubernetes cluster, then always label the nodes within a respective node group. This helps with the node selection while placing different Couchbase services like data, index, query, eventing, etc. during the deployment. Whenever possible, utilize multiple availability zones to improve the availability of your cluster. And last but not the least, always use persistent volumes to improve the durability and reliability of your cluster. Next, I'm going to double click on each of the bullet items. In a distributed database like Couchbase, we don't want to place master data and its replica on the same physical node. And if you are not careful in the Kubernetes environment, then it is very easy to place multiple pods hosting master as well as replica of the same data partition. Now assume if the node hosting multiple pods fails, then it may lead to data loss as both master and replica of a specific partition of the dataset could be on the same node. Therefore, to guarantee the placement of one pod per node, you can simply set NT-affinity to true property in your Couchbase cluster deployment YAML file. We will use this setting in our demo as well. Second, perform sizing analysis to determine the count and capacity requirements of your worker nodes. As discussed in our first recommendation, each worker node should host one and only one Couchbase service pod. Therefore, the sizing estimates are going to be for the worker nodes only in the Kubernetes environment. One more thing, that is, always build your node group with instances that maximize the cost to performance ratio. For example, we prefer memory optimized nodes for index service, compute optimized nodes for query service, and depending upon the use case, maybe a general purpose node could be a best option for your data service. The important thing I'm trying to highlight here is that with so many options of instance types available on the cloud, recommending the right one is always an important outcome of a sizing exercise. Third, always label your worker nodes in a node group. To make sure each Couchbase service gets desired resources, label all the nodes in a node group with the name value pair. On right, you can see when kubectl get nodes command is run with -show labels option, it displays all the labels that exist on that node. You can use any one of the label as name value pair for the node selector property in the cluster YAML file. Doing so, Couchbase Autonomous Operator guarantees that the resources assigned to a specific service is consistent throughout the cluster by placing the pod onto the desired label node. Fourth, always distribute cluster across multiple availability zones. I totally understand that for many use cases, high availability delivered by a data replication and service redundancy in a single availability zone is enough. But I have observed that even for business critical application, customers do not leverage Couchbase automatic easy failover feature because they think it would be complicated to implement. Well, let me tell you that with Couchbase Autonomous Operator, it is as simple as setting server group property in the cluster deployment YAML file, which we will take a first-hand look in our demo too. One last thing on this topic, that is, always distribute Couchbase service equally among at least 3 availability zones if you would like auto failover capability in the event of easy failure. And last but not the least, persistent volume provide decoupling of storage volumes from the pod. Therefore, when a pod fails, operator simply brings up a new pod and attaches the old volume to this newly provisioned pod, leading to faster recovery. In the latest version of the operator, if for some reason you end up needing more space after provisioning the cluster, then all you have to do is change the size of the storage under the volume claim template. All these changes in the traditional deployment method may take a long time to plan and execute. This concludes the theoretical part of the presentation. In the next section, I'm going to demonstrate these best practices by deploying a real Couchbase cluster on the Amazon EKS platform. For this part of the presentation, I'm going to stop the video camera so there are no network related issues in the middle of the demo. All right, now let's jump right into the fun part. In our demo, we will first deploy the Couchbase cluster across 2 availability zones using the persistent volumes. We will then test the self-healing capability of the Couchbase cluster by killing a pod. And finally, we will perform rolling upgrade by just changing the version number in the YAML file we use to deploy the cluster in the first place. Let me summarize high-level steps one more time so it's easier for everyone to follow the demo. We will be deploying the Kubernetes cluster on the Amazon. So we will use eksctl command to deploy the control plane, also known as Kubernetes master. Next, using the eksctl command, we will create a couple of node groups of different instance types. This is where we will be deploying our Couchbase cluster finally. But once the node groups are ready, we will go into our Couchbase Autonomous Operator directory and deploy the admission controller. Once the admission control is there, we will then be deploying our Couchbase Autonomous Operator. And finally, with everything in place, we will use our Couchbase cluster.yaml file and deploy the Couchbase cluster across different node groups. All right, so that's the demo summary. Now let's get right into the demo. Okay, so we're going to be using a lot of commands here, and you don't have to worry about how you can find those commands. I have published a blog back in July, the link for this blog would be in my resources section, so you can find this blog very easily. So I'm going to be just using the same blog to copy paste some of the commands to deploy the cluster. And as I copy paste things from the blog, I will explain to you each and every step. Now, as I have already discussed about the best practices, so I'll just scroll through. Prerequisites, of course, you should have AWS CLI configured, kubectl configured in your environment, and of course, you should have downloaded the Couchbase Autonomous Operator, which, as you can see, in the lower terminal window, I have a few versions of Couchbase Autonomous Operator. The latest one is the 202 for the Mac OS. So this is where I will get into. And once you are in the directory, you would find some of the YAML files right out of the box. But there are some YAMLs that we have modified it, and you can find those YAML files as you go through this blog, right? So you can copy those YAML back into the same directory, so it's easy to run it. So let's get started by copy pasting this EKSCTL command. And what it does is it creates just the control plane using a CIDR block 172.16.00/20 in two availability zones, West 2A and West 2B. And the name of my cluster would be Kubernetes EKS. So let me copy and paste it here. I think it will take few seconds to few minutes. So let's just wait for the control plane to be ready. And once that is ready, then we will be deploying two node groups. All right. So my control plane is ready, and it's in the West 2 region. And let's first confirm if my context is set right. So I believe the command is kubectl config get context. All right, so that's my cluster. If I deploy a multiple cluster through kubectl, then you would see multiple entries of those contexts, right? So you can switch through different cluster contexts. In my case, it's only one. So get nodes, this should show no resources yet, because when I deployed the control plane, I used without node group option, right? So if you want, you can deploy just right after the control plane, you can go ahead and deploy a node group as well. But in my case, I wanted to have two separate node groups. And therefore, I would first use a node group for M5 large instances, right? So this will have minimum of 2, maximum of 4 nodes. And let's go and get this going. So in M5 large, we will place our data service nodes. And to place the index and query nodes, which in your production environment would most likely will be a memory optimized instance. Therefore, I'm using a memory optimized instance in this case, which happens to be R5 class instances. So let me execute that command as well. So just like M5 large, here I'm using R5 large machines, which will be in the same region, minimum with 2 and max of 4 instances, right? So let's go ahead and deploy. Okay, my multi-factor authentication token was not set, so I set those tokens here again. So let me give another try. Copy and paste the command, and this is R5 large. Okay, this time it seems happier, so I'll let this proceed. All right, as you can see from the above window, my M5 pool is ready, and just now R5 large pool, which is the node group, is also ready. So why not we go ahead and run the kubectl get nodes command. And there they are. 2 of those machines should be the M5, and 2 other instances should be the R5, M5 and R5. All right, so what we have done so far is we have deployed our control plane, the Kubernetes master stack, and then we have a couple of node groups ready. So next, as we learn in our best practices, that we will be using the labels to place the different service types onto a specific type of a node group. So in this case, we will be using a label that comes out of the box, and the label is called as instance type. So what we will do is kubectl get nodes show labels, and this will show us a bunch of things, and the label that we are interested in is the instance type. So the important thing to pick from here is the label name, and I'll show you later on how we use this label to place Couchbase instances on a specific node of this label type. Okay, so this section is done. Next, or create a namespace called CBDB. Okay, so kubectl create namespace CBDB, Couchbase database. Yeah, this is the command I was missing, the CRD. So let's make sure we deploy this as well. And by the way, the CRD YAML is right in our Couchbase autonomous directory, okay? And by the way, we created the namespace before the CRD. That's not a problem, all right? I knew I'm missing a command here. So sorry about that. So we got the CRD going, we have the namespace. Next, what we will do is, as in this picture, we will deploy our admission controller. All right, so the command is, under the bin directory, there is a utility called cbopcfg. So let's copy this command. And we have our admission controller started. You can do get deployments command, and it should show us that the admission control is there, but it's not ready. So let's try one more time. And once it's 1, that means it's ready and serving our request. Okay, so admission controller is deployed. And by the way, we deployed it under the default namespace. But when we will deploy the operator, which is the next step, we are going to be using our namespace CBDB, all right? So let's copy this command again and deploy this command. So let's confirm that our deployment is running, our CB operator deployment is functional. And as you can see, the operator is ready as well. By the way, at this point, we can do get pods namespace CBDB, and this is the operator name. All right, so we will be looking into the logs once we deploy the Couchbase cluster in just a few more steps, but let's continue. Okay, so we got the controller, operator, everything up and functional. Next, we have to just deploy our Couchbase cluster. And the Couchbase cluster YAML file is right here. So if you click this file, it will show you the exact same file that I'm using here, all right? So let's go back and finish these 2 steps, which would be needed before we deploy our Couchbase cluster. So the first one is that we are deploying or creating a secret file or credentials under the namespace. So let's do that. Next is we are going to be deploying a SSD-based storage class. So let's go back and create this storage class as well. Okay, so that's done. And now the last step is how we put everything together and use different storage volumes to build our cluster. Okay, so in the cluster, Couchbase cluster YAML, you would see at the very bottom, there is a volume claim template. And now that we have deployed our storage class by the name NAS, we will be using that storage class and build different volumes, all right? So the first volume we will make is called persistent volume claim default. This is where we will put all the Couchbase binaries. Next, in this cluster, we will be deploying data and nickel as well as query, all right? So query doesn't need any storage, but data and index does need storage. So I will be defining separate mount volumes. For the data, I would call it MVC data, and I'm giving it 2 gig space. In production, you would be doing the sizing exercise based on your workload, the average size of your documents, average key size, and all bunch of important things. And I already mentioned about that in my best practices. So in this case, I'm just giving 2 gig. The third volume I'm defining here is called PVC index. This is for my index service. And I would be using a 3 gig space for my index service. All right, so that's the volume claim template part. Next, if you scroll up, you would see a section called servers. This is where we define different kind of servers, services, and map different volumes to those services, right? So in this case, under the servers, I'm defining a service called data, giving it a size of 1 and associating that in the West 2A region, all right? So this name should map to the region which is, so if you go back to your get nodes show labels command, one of the label also talks about so this one is the region. So the other one will be the availability zone, which is this one. So whatever is the zone you want your services to be placed in, it should match, right? So make sure that the label that you use in your YAML matches to the label which is there in your show labels output. So let's go back to the blog, and we will just simply copy paste this command called kubectl create -f couch cluster YAML, which is already there in my working directory under the namespace cbdb, and I'm saving the config. So this command will go very fast, but it might take a little bit of time for all the pods to come back or all the pods to be running, right? So we are deploying 4-node cluster. 2 of the nodes are data type and the other 2 are index and query type. And both of these instances of different services would be spread across different availability zones. If I now do kubectl get pods under namespace cbdb, I would see that my cb demo 0000 pod has just showed up, but it's not ready. So why not I put this under the watch, so every time there is an update, we'll get to see the state of that pod. And in this window, let's do a log output as well. So I believe the command is kubectl logs, the name of the operator, which is this one, and it's under namespace cbdb. Okay, let's put this under F so I can see that in action. So it is creating first pod. Oh, by the way, it's now moved on to the second pod. I believe at this point, we can set the port forwarding, which is this command, and connect to the Couchbase cluster console, all right? So not sure which one should I cancel. Okay, let's do it here. Okay, so at this point, I can go back and type localhost 18091. Now 18091 is HTTPS port, HTTPS. Yes, I trust. Okay, and in our secret file, we use administrator, and the password was password. And I'm sure in your production environment, you would be using more tighter credentials than these common ones. But as the cluster comes up, we can see the state of our cluster through this UI. So we have 3 of the 4 nodes, aka pods, ready. Let's just wait for a couple more minutes. So all 4 pods are ready. And as you can see, without touching a single button, our cluster just rebalanced by itself. So now you can connect to this cluster through your client and you can run your CRUD operations. The other thing I want to highlight again, as you can see, these are 2 data services and these are our 2 index and query services. This is our server group, West 2A and West 2B. And we have data as well as query index spread across equally to both the availability zones. Okay, so that concludes our first part of the demo, which is deploying Couchbase cluster using persistent volumes across multiple availability zone. I would also suggest that in production, if you want to take advantage of auto failing over the availability zone, so you would be using 3, not 2 availability zones, right? Now let's move on to the second section, which is the automatic healing or self-healing aspect of the Kubernetes cluster, right? That's why we are deploying our Couchbase in Kubernetes, because we want Kubernetes to manage, monitor, and heal our cluster whenever there is an issue with our cluster. So to induce that failure, what we would do is we will delete one of the pod. So let's first get pods under CBDB. And as you can see, we have 4 pods running, and my port forwarding, I believe, is on first instance of the Couchbase. So I'm not going to delete that because then our UI will be unavailable. So kubectl delete pod. How about I delete the third one? CBDB. And as soon as I delete, you can see that the node becomes unresponsive. And we just have to wait for our auto failover setting, which I believe I did not change it. Oh no, I did. So I made it to 10 seconds. Default is 120 seconds. So within 10 seconds, Couchbase will detect that there is a node failure, and then Kubernetes will pick that as a exception, and then Kubernetes will spin a new pod and would assign it back to the cluster. And we actually can see as things happen by going into the log. So why not we copy the operator name? So k logs, that's my operator. And I will put that under -f. Okay. So what do I get? It has already healed my 003 instance, right? And you can see I didn't have to do anything. It just spin up by itself a new pod 0003, and then assign it back to the cluster, auto rebalance, and voila, my cluster is back to its normal state. Okay, so that was step number 2. The third piece, which I promised to show you in this demo, was to change the version of my cluster. So currently my cluster is at 650, and I can confirm it right here. If I go to dashboard, you can see my cluster version is 650. Okay. I wish I had 3 terminal windows, but I just like this setup. So I have to kill one of the processes which are running in the background, which I'll do it in just a minute. But why not we change the version of our cluster from 650 to 651? And that's all you have to do, all right? So whenever you are doing an upgrade, you will just change the version of your cluster. And then let's take this space back. So next we will apply the changes by running the kubectl command. Couchbase operator will manage the upgrade of your cluster one instance at a time. And by the time it is done upgrading all the pods of your cluster, all the pods in your cluster will have different pod names. So make sure you never use pod names in your client application, but use SRV service. You can learn more about this from the operator's documentation. Thank you. That concludes my demo. If you are not already using the chat channel to ask your questions, then please feel free to ask them now. I will do my best to respond them in timely fashion. And last but not the least, here are some of the useful links I referenced throughout my presentation. Thanks again, and I look forward to helping you with your Kubernetes deployments.